If she's in the office, her door was open. So it's like,
they're on lunch break. That's where it's
out there. Usually there's cop cars that come around.
Take a nice long break.
Hey, boss, they're on a lunch break. Can you open the door? Like, let the smell out?
Yeah, please.
Sure, of course.
Well,
It smells worse in here than it does outside.
No,
it's not too bad.
Better out there.
It's not as bad out there. It's always nice to see a danger sign right outside the door. Danger.
oh, yeah. So how timely is that?
All right. So let me show you a really common mistake that people make with this kind of thing. This looks almost too easy here.
Too easy.
It's not as easy as some people try to make it. Let me ask you guys, what mistake do you think people make here? This is interesting. I never really asked a question like that.
They try to just add a 3.
I like it. Exactly. They say this, oh, cool. There you go. We got 7 of them. That doesn't make a damn bit of sense, does it? Then you could say like 1/2 is equal to 2/3. Add 1, yay. Or you can even say something worse. 1/2 is equal to 0 because you subtract 1, subtract 1. You're like, oh, you owe me $500,000. Oh, you owe you 0. Sweet. Right? So you know already you can only multiply or divide fractions, but the problem is students still see this as a fraction because they say, okay, there's a variable in it, everything changes. Nothing changes. It's just a part that I don't know. That's why it's harder, but nothing changes. I still need an LCD. What does this guy have?
X.
Now, does this guy have an X? No, he doesn't. When I say does he have this, I'm saying is this a factor of it? X is not a factor of this. Right? If X was 5, then that number is 8. Does 8 have a 5 in it? No, I know it's 5, but it doesn't have a 5 in it. It's not a factor of it. So what has he got that he's missing then? The whole damn thing.
X. So, yeah.
Oh shit, they're back.
I guess lunch was short.
Fired.
Yeah, I should have taken a longer break.
No, just keep.
And what's he missing that he's got?
And multiply the other side by X.
Here, let's go.
Maybe, yeah. So he's missing an X.
You guys are choking us to death.
I'll say that to them.
They're pumping tar onto the roof.
Pump it even worse now.
That's what that smell is.
That's how you, yeah.
Well, that's how it's
That's how you do it. Alright, so what goes on the bottom here? What goes on the bottom?
X times X plus 3.
I feel bad.
On the top, what do you get there?
4x. Oh, yeah.
I'm with you, a little ahead of me, that's alright.
Okay.
I'm not that fast. So 4x is 2x, there's your 6x. The top will factor, but you can take a 6 out and you'd be left with what?
X plus 2.
And there's no x plus 2, so no reason to do it. If you do it, it's not wrong. You do it and you go, I can't do anything with that, so that's it. So there you can stop, or there you can stop. I don't care.
Why wouldn't you make the bottom like 6x plus 3x? Or, I'm sorry, x squared plus 3x?
You could, sure, but there's no reason to do that.
Okay.
It's actually a little better to leave it factor because most things you might have to do next are easier if you leave this factor. We don't have anything to do next, so it doesn't really matter.
Okay.
But I'm just saying, don't waste the time multiplying that back out. Leave it like that. Yeah.
What if you took 2/3?
Say it. Okay. So the next level, let me just give you a problem and see what you guys think about this. Here we go. All right. Let me actually start us off with one we know. Or we should know anyway. Now, I think most of us deal with this kind of problem a certain way, and I'm going to do it that way, but I'm going to show you how Another way to look at it actually makes it easier when you have more ugly stuff down there. This one's not that bad. Whenever you have fractions in an equation, how do you kill them if you want to? Here I have to, because my variable's down there. What can you do to kill the fractions?
Multiply it by 1/4.
Multiply by the LCD. What would the LCD be here?
18.
9x. The numbers need 9, and you have to multiply the x to kill that guy. So you can build it up by what all the parts are on the bottom. So if I multiply everything by 9x, and why am I allowed to do that? Why am I allowed to kill the bottoms here? I got to be real careful. Every time I tell people about this, they go back and kill the denominators here.
It's an equal sign.
Yeah, it's an equation. I have two sides that will balance me. If I multiply one side, I multiply the other side, everything's good. Here, I've got one side. I can't just multiply that. I'll get people like 2 sevenths minus 1 seventh. Well, let me multiply by 7. That's 2 minus 1 is 1. Yay! No, we can't do that. How can you kill the 7? Can't. I got 2 sevenths of a dollar, 1 seventh of a dollar. I got $1. Right? I'm awesome. No, that doesn't work. So here, you multiply by the LCD because that'll kill all of the denominators. It'll overkill some of them, but I don't care. Here the x cancels, so you get 36. The rest of the day is just going to be me doing it. Here, the 3 goes into 9 3 times, so I get 6x. Good. 2 times 3x, right? Here the 9 cancels, so I just get 5x. And then that's an easy problem, right? Bam. Can't beat that. That's nice. So most of these problems in this section will be one step away from a nice one-line thing. That's awesome. Just get your x's on one side, numbers on the other side. No big deal. Here's what they're going to look like then in this section. They're going to look like this. That's fine. Now, the only thing you can factor there is not difficult to factor, but do you see how the problem tells you how the stupid thing factors? Assuming I did it correctly in my head. Yes, I did. Right? I mean, this isn't hard to factor, but it's got to factor like this times this, so that they have something in common so you can see what they're missing, right? How we doing? So obviously, I mean, this guy factors 24 is 8 and 3 to make 24, to make 5 also, and the 8's got to be plus. Now, I do that kind of problem a little differently than this kind because it builds off of what we had to do here. I love the idea of factor, see who's missing something, give it to them. That's very simple. Who's missing something here?
The 4 and the 5?
Yeah, the first dude's missing a what?
X plus 8.
X plus 8. I didn't need that, but X plus 8. The middle guy's got everything he needs. This guy needs X minus 3, right? There we go. See, that's relatively easy, and it builds off of what we were doing in the previous section. You could multiply by the LCD. It gets a little bit harder to manage when you got these larger, uglier expressions. We're more used to giving them what they're missing, because now if I multiply by the LCD, don't they all cancel? What's the LCD? This. So if I multiply that, bam, 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 bam. They just all cancel, right? You could have done this the same way. You could have said, okay, this needs a 9. And see how that's my 36? This needs a 3 times x, right? There's my 6x. I mean, do you see how I could have done it the same way? And I actually think it's a little easier to look at when you get more discussing stuff. So what's left alive here? What do I get there?
4x plus 32.
Good, so 4x plus 32.
You don't have to.
Say it.
How you cancel them all out right there. You don't have to times the top ones now by x minus 3, x plus 8.
Are these still alive? if I multiply each piece by this, it dies, so there's nothing left over for the top. Do you see what I'm saying?
Yeah.
So once I get all the bottoms the same, I can effectively cross them out, because I can multiply by it, it cancels.
Like I did that, yeah, but I just put x minus 3, x plus 8 on the bottom still, so it's done for. I don't need it anymore.
How do you mean, I'm sorry?
Like I did that, like 4x plus 32 plus 2 equals 5x minus 15, then I put it over x minus 3, x plus 8. I don't need to, that thing's completely gone under there.
Yeah, it's gone.
I don't need them anymore?
No,
Okay,
yeah,
so
yeah.
all my x's are up top, and that's the equation I need.
And thank God you don't need any more, because that's easy as hell to do,
Yeah.
right? Because it's an equation, I can multiply both sides by anything except 0, right?
Up top.
How are we doing there? I can multiply both sides of the equation by whatever the hell I want to except for 0. Because then I get 0 equals 0, it doesn't tell me anything. So here I multiply both sides by the same thing everybody's got on the bottom so that they all cancel. So what's left is everything that's on the top. And look what I get. I get this freaking cool little stupid little equation, the easy as hell to solve, right? In fact, this was like, especially, I didn't do this on purpose. I'm surprised it came out so nice, but the x's go together really nice. Right, I get x equals 49. Crazy. Don't worry, we're going to do a few more. All right, let's see. Does this sound familiar? Most of you guys should have done something like this before.
I'm just having trouble with like what he was talking about. Like you're canceling out the bottom, but it's only on top on the first part of the equation.
All right, let me do this again. The same problem. We do the same problem. And real quick, why is that there? Because I had to multiply it to make it the same as everybody else. So then when I multiply by the bottom, that cancels, that stays there, of course. Because there's nothing to cancel it out with. Those die, those die, those die.
Okay, so you just threw that up there after the fact, just to
No,
on
I
the
threw
left.
that up there on the way, because
No,
that's
on the
what I was
left.
missing. Yeah, that is the next step. That is multiply
That's
by
what-
this
I
to
think
kill
that's
them all.
what
Because you could take that problem. Some of you guys are used to doing this. You could take that problem. Oh, it's plus here. Some of you guys might be a little more used to this, but personally, I don't think it's as nice. But if you're more used to it, it's better to do it that way. If you immediately multiply by the LCD, in which case I would highly recommend you put it next to everything. What happens here? This cancels, so the 4 picks that up. Same thing happened to me, right? Both of these cancel, so you just get a 2. Over here, the x plus 8 cancels, 5 picks that up, just like it did over there, right? Mathematically, it's the same thing. It just depends on which way makes it easier to think about for you, right? I don't care. Either way is fine. You end up at the same equation, both situations. Cool. Now, x equals 49. If you wanted to check it, you could plug it back in. It gets a lot more disgusting, obviously, with fractional stuff in there, right? The big key is I didn't get an answer that I have to throw out. Can anybody tell me what answers would you have to throw out here?
A negative 8 and a positive.
Yeah, if I got x equal -8, that obviously can't work because it makes my equation undefined. It makes a part of my equation freak out. Or if I get x equal 3, I got to throw that out also. The reason math gives me answers that don't work, then you can really get upset at math. You know, math you're hard, and now you're giving me freaking answers that don't work. It's because we came in, didn't we do this? We multiplied by this, didn't we? So if I get x equals to 3, math is saying you multiplied by 0. I can do whatever the hell I want to, right? So if it comes out to x equals 3 and that makes this undefined, we did something here we didn't know yet we couldn't do. We can't multiply both sides by 0. We didn't know we did that until we get to the end. The 49 is fine because it doesn't make anything undefined. If I got 3 or -8, no solution. I got to throw out the only possible thing, so there's no answer. You're going to see a few of those in the homework. You've got to check your answer at the end. Make sure it doesn't make anything undefined. Yep.
Just to be clear, when you put that up there above the 2, the Roman numeral 2, you're saying that whole problem is multiplied by.
Yes, so I'm distributing it across. So I was just trying to save time. But yeah, I'm putting it next to everybody. So it cancels there, it cancels there.
Okay.
Cool.
I'm just writing it once for all.
Because once you multiply one side by something and multiply the other side, which means distribute, so it goes to each piece. Cool. Okay. If you understand the idea, these problems become really nice. Let me see if I can get us to that point. I don't know if I can be lucky again with getting a nice answer. Let's do. That looks freaky. Let's do 39. Oh, good. Which page? Page 479. So again, how do you think this factors? You don't even have to really think about it. Like this. The funny thing is, the ones that end in 6 are the evil ones because 2 and 3 make 5. But so do 6 and 1 if they're opposite sides. So it's, believe it or not, that looks easy, but it's really easy to make a mistake here. That's where these come in handy. Check it. You get minus 3x plus 2x is minus x. See, so that is how that factors. So this factors like this: x plus 2, x minus 3. So either way you want to do it, either way you do it, you pick up what this guy is missing. So the way that I try to teach it is you directly give it what it's missing. You know, it's like, what's he missing that he's got that the other people have?
Plus 2.
X plus 2.
X plus 2. What's he missing?
X minus 3.
X minus 3. There's a step that you got to be really careful about, but it's awesome if you understand what goes into it. It's an equation. I'm allowed to multiply and kill the bottoms. If the bottoms are all the same, they cross out. Because it's going to multiply by the bottom, am I not? I would just multiply everything by this. So they would cancel. That's why I really like this method. Give it what they're missing, kill the bottoms. You got a nice equation up top. And again, it's just because of the fact that I can multiply everything by this, so it will cancel in each situation. It will cancel for each denominator. You guys look very concerned. Let me do that again. So you got poor little dude's just about done. So here this factors like this. Right? I can multiply both sides by the LCD. I can do that after I mess with each piece though. And that actually makes it easier because this guy needs an x plus 2. This guy needs an x minus 3. Right? Now if I multiply each piece by the LCD, and what's the LCD? Well, the LCD is that, because they're all the same. If I multiply everything by this now, so now I've made it legal. I multiply both sides by this. That cancels the bottom, that cancels the bottom, that cancels the bottom. What's left then? Everything that was on the top. It's freaking awesome. Since I have an equation, you're allowed to try to get rid of what you don't like. Because if there's a way to do it, you just do that same thing to both sides. So I don't like the freaking bottoms. Okay, multiply that. I can do it to both sides. Hey, everything's gone now because I made them all the same. They're all gone now. So what do you get? What's left over here?
3x plus 6 plus 5x minus 15 equals 5x.
I like it.
Maybe you combine.
Yeah.
No solution.
Yeah, here, do you see this so the 5x's cancel? Well, let's not do that.
No, why not?
8x.
That'd be horrible.
What's wrong with that? Subtract 5x, they cancel. If there's the same thing on both sides of an equation, they just cancel. If you don't like that, cool. What's so I get 8x. What's 6 minus 15? I love that reaction though. What? Plus 5x.
It makes sense though,
because you end up with the same answer.
minus 8x. So you get x is 3, because you gotta divide by -3, right? Now, what happens there? What's the last thing you have to do?
Check the work.
Does 3 make anybody freak out?
Yeah, the first one.
Yeah, it makes this guy freak out and that guy freak out, right?
Oh, yeah.
All it needs is 1. If anybody freaks out, you gotta throw it out. So what's the answer?
No solution.
No solution. The only possible answer didn't work. So there's no solution.
And you have no problem with the 0 with the blank thread.
Oh, that's fine, because that means empty set. It's like, give me the set of all the answers. It's empty. Oh, so there must be no answer then. Yeah. I like it. Maybe. There, you guys try one.
So when you were doing that earlier, where you just did the, you canceled the 5x's on both sides, you were just one step shorter than going all the way through like we just did. Like when you just said, like cancel the 2 5x's
Yes.
and end up with 0.
Oh, that
Yeah.
step wasn't that important, really. Yeah. All right, so try this one here. Let's see. Yeah. Yeah. Okay.
I did,
I change it. Try to make sure you guys see that's a Y and not a 4. Where?
She wants to know where you got that.
So here we got 3 times x plus 2, so 3x plus 6, okay? And then plus 5x minus 15. So just distribute up here, that's all you
And the bottom canceled out because it was the same. So.
Yeah, and I have an equation, I'm allowed to multiply both sides by anything except 0. I'm going to multiply by the thing I want to die. I don't like the bottom there. I think that's pretty simple. Yes, cool. Extra steps in it.
I like your canceling technique for this one.
Mm-hmm.
Hmm?
So I like your little cancel technique for this one.
All right, that makes me feel a little better.
Yeah.
Well, it's really, you're doing the same thing, you're just doing it
Doing the
in
same
a different
thing.
order.
That's why it doesn't matter which way you do it. I just like the idea that the giving it what it's missing idea is exactly what we did in last section. It just kind of carries over.
And if you do it the old way, you're pretty much doing the same, you're just
It's just harder to
Having-
track, I think.
having to cancel more.
Yeah. So here, obviously, well, let me let you guys. That's right. That's right.
I see.
Let me try to catch up to you guys. So the only thing factor is that guy, and he sure enough becomes those guys. So now you can see what this guy's missing here. What's he missing? Good. And this guy, of course, is missing the y plus 2. You can see how, though, the minute I show people that the bottoms can go away, they try to make the bottoms go away everywhere. Why is it again exactly that I'm allowed to make these bottoms die?
Because multiply the whole.
It's an equation.
Yeah.
It's got two sides that can balance each other out, right? Because of this, I can do this. Die. Because again, what am I doing? I'm multiplying both sides by this. So of course it cancels everywhere that it is. That y minus 2y plus 2 cancels because I'm going to multiply by it. So what am I left with here? Yeah, so you multiply that out.
3y minus 2y minus 2y.
Cool. Alright, so FOIL that bad boy out. Minus y. Don't freak out. You need to. 3y minus 2y is y minus 6. Minus y equals. Bless you. Now remember I said if there's a higher power on your variable, then you have to do something freak. But what's nice about the y squares?
Cancel each other
See,
out.
now you're okay with it. If it's the same on both sides, it cancels, like I was trying to do earlier. But yeah, so that's gone, right?
You can also
Minus it is gone. And then y minus y is gone. So your negative 6 equals 2y. So y is. Is that okay? As far as, at least it doesn't make anything undefined. It's not checking it, but it's making sure that that answer doesn't make it undefined. So that looks okay. Alright. Because again, you could check it by plugging a negative 3 in everywhere. Like I said, though, it gets a little uglier because now we got fractions built in. Okay, let me. Oh, you know, let's try this. I want to show you something interesting about, let's do this problem in the calculator, just to show you. So everybody's got this here, right? Where the answer negative 3. Remember that? I'm going to show you something nifty. Stay with me. Which one was that again? There it is. So if you take these broken, no. If you take the problem, now remember I said this last time, I'm not sure if you guys really picked up on this, but every single equation that you get, you can solve it in the graphing calculator. Because you put one side in for y1, the other side in for y2, and you find where they intersect. Because what's an equation really say? This function equals this function. Where does that happen? Visually, where they meet. That's kind of silly. So if I put into here, let's see if we can do this correctly. Where'd it go? There it is. If I put in there, and again, I got to tell it the top. And do I have to use y? I know the format is y, and I can just put an x instead, right? It's just a variable. It doesn't matter. So if I put in there x plus 3, get in there, divided by x plus 2. Just putting the function in there, right? Minus x divided by x squared minus 4. How are we doing so far? So that's the first side, right? That's the left side of the equation. Cool? X's instead of y's because they don't have a little y button. They got a little x button. Okay. That's one side. Now in y2, put the other side. Y over y minus 2, so it's going to be x divided by the bottom x minus 2. So notice the parenthesis placement here, right? Got to tell it what the top is, got to tell it what the bottom is. Notice I didn't put parentheses around the x, because if it's one term, it's pretty obvious that's the top. Cool. Alright, so does that look alright? So I've got the left side of the equation, I've got the right side of the equation. If I graph it, the answer should visually be where those two things meet. This is where it gets funky though, because now we got these graphs that are going to look like, you know, and I don't care what the hell they look like, I just look for where they meet. So let's see, what did you get when you graph? I have no idea. Neato.
Whoa.
All kinds of shit happens. Let's try. Let me show you a little. Let's see if I can do this. No, that's the best I can do there. All right. So we can go into this knowing that the answer should be at what was it? 3. Negative
Negative
3.
3.
Okay. So it graphed it a little too quickly. Now on yours, maybe it took a little bit longer. The problem I'm having now that it's graphed, and because it's so convoluted with all kinds of crap, is I don't know which one's what. Here, right? You guys with me on that? Okay. If I zoom in, if you watched it as you graphed yours, it might have been easier to catch where it met. So let me zoom in on the part that, have I shown you ZoomBox yet? I think I did it earlier, but I didn't really talk about it. ZoomBox is a kick-ass, coolest little zoom that we have. It's a lot like Google Maps or something. If I zoom, if I hit ZoomBox, you see how I can move that little tiny plus sign around? If I hit enter, that'll be one side, one corner of a box, and then I can open the box up and it will zoom in on that piece. Sort of like on CSI, they say, enhance this area here, which computer people laugh at, but that's right. Let's see what I can get if I zoom in around here. Ah, see? You can see the lines meet there. Let me try that again. It's just too fast. Let me change it a little bit so it'll redo it. Now watch it as it draws. Watch the first thing it draws and then watch what it puts on top of it, right? Don't worry about what I'm doing right now. Look away. I'm just trying to force it to redo it, okay? So now watch really carefully. So it's going to draw one line and it's going to put another one on top. There's one line and there's the other one line on top. Do you see how we have some overlap here? Definitely here, right? So remember, how do I find an intersection? Where do I go to find an intersection? Second trace. Number 5. And the nice thing about intersection is, oh, that's kind of nifty. Put it close to where you think it happens. So somewhere in here, right? And hit enter, enter, enter. There's it, -3. That's the answer we got, right?
What if you go to table, man? Can you still
If you go to table, you could maybe see it. We're lucky here because it's a whole number, or integer. If it's not, you could still kind of catch where they're getting close to each other and say maybe it's around in there. So if I look at the table, here's the cool thing about table now. I have, how many functions do I have in there? 2. So it's going to actually give me an x, y, 1, y2 table. I've got both functions here. Holy crap, and I'm way at -21. This is particularly ugly. Well, see, here you can see it just pops out at you. They're the same right there, right? If you're not lucky and it's not an integer, whole number kind of thing, it actually is not terribly easy to see, because see how close they are back here? They get really close back here, but they don't actually overlap. So that's why it's better visually. And do you see what I meant by, when you graphed it, didn't it do it a little bit slower? When you graphed it on yours, it didn't do it as fast as mine. So it's easier to kind of keep track of which one's which. Okay, so the bigger point I'm trying to make here is, whatever equation you're dealing with, you can always take it, before you do any work, just to check your answer, take a very original one, put the left side in y1, the right side in y2, see if they meet at the answers you got. Right? So if your answer was 0, you're wrong. I mean, it doesn't come anywhere near meeting at 0. But if your answer is -3 or something, hey, it looks like it should be right. That's about where they meet. See that? All right, all right. Cool. Oh, stay. All right, so I just want to do a little bit more, and then I'll let us out of here early before we pass out.
and distribute it? Go ahead, I'm sorry.
Why would we do that?
Now notice on the homework sheet that I gave you guys, 6.5 is now extra credit. 6.5, for those of you interested, is a few applications with rational expressions.
Because it already has.
The way to say that quickly is
You're
word
not adding
problems.
it.
So whenever you see applications, that really means word problems. I want to do a little tiny bit out of 6.6. I'm going to leave 6.7 for next time. 6.6. is division. So in a sense, what we're doing with something like this, I can reduce that, right? But that's not really dividing it, is it? I mean, if I reduce this, that's not dividing it. Dividing it would be 8 into 6 and dividing it. So there's a difference between reducing and dividing. We know that, but it gets a little weird when we start having variables in there. So how in the world, let's see, divided by, let me ask this real quick. Anybody here who moved here from a European country or from somewhere else that maybe did their division? When you do division, did you learn it to set it up like this? Anybody didn't learn it this way? Don't worry if you did. Let me know, or come see me if you did, because this is going to be built on writing it like this. And in other countries, they actually divide things differently. They don't do it this way. They write them in different places. Personally, I think it actually sort of makes a little more sense, but this is the way that we decided to do it. Remember long division? There it is. So in other countries, they don't set it up like this. Off the top of my head, I can't remember exactly how they set it up, but they have things going in different places. Here, so some of you guys kind of catch on to this, we're going to do long division with variable expressions. So there's no way to sugarcoat that. So let's remember how to do this, because it might be a while since any of us actually did long division. So how do you do this?
7 goes into 8 once.
So it goes in once. 1 times 7 is 7. You change its sign. I'm going to say it a certain way. It's going to help us with that. Right? You actually subtract the damn thing, but don't, isn't that saying that it changes its sign? 8 minus 7. Bring the 9 down, right?
Goes in there twice.
7 goes 19 twice. 2 times 7 is 14. Change its sign.
Goes in there 7 times.
7 times. 7 times 7 is 49. And we're going to write it, yeah, we're going to write it the way we should, not big old R1, unfortunately. That's
Or you could
great
raise
or something. What does that really mean, that remainder 1? What does that really mean? Who knows kind of like what that means?
It's like a degree of that number, right?
890 is 1 away from the number that 7 would go into evenly. Do you guys get that? I mean, that's why there are remainders. I mean, 7 goes into 7 once, 7 goes into 8, once remainder 1. Or the better way, of course, is 1 and 1/7. That remainder tells you how much over or under this number is from something that could go into evenly, right? Just to really kind of take one-step analysis of remainders. So this is going to work pretty much the same exact way. You know, when I see long division with variable expressions, there's just no way to make that sound good. It really isn't. So it's sort of like I'm a politician trying to tell people that we have no money. Go away. There's no way to say it nice. Just say it. It will act a little differently than you might think, though. I mean, the weird thing is I don't know what this number is. I don't know what y is. I don't know what y plus 2 is. So what I do is I work with the parts that I can. Y times what is y squared? 1. And then I do the same steps we just did. Y times y is y squared. Y times 2 is 2y. Change the signs. Now you see why I said it that way over there, right? Is everybody cool with that? So y goes into y squared, y times. Y times y is y squared, y times 2 is 2y. Change the signs. Y squared minus y squared, of course, cancels. That's what we desperately want to have happen. 4y minus 2y, 2y. Bring down the 5. How we doing? This should feel very similar. It's exactly the same thing we did over there. Y goes into 2y 2 times. 2 times y is 2y. 2 times 2 is 4. Change the signs. I love it. So the remainder would be plus 1 over y plus 2. So let me say this. Can you tell me what that means then about this and this, that remainder?
1 degree.
One number off.
number
If
off.
this was a 4 instead of a 5, this would be y squared plus 4, y plus 4. And of course that factor is like y plus 2, y plus 2. So it's 1 off from something that this could go into evenly. Are you guys with me on that? It's 1 away from something this guy could go into evenly. And that's part of what the remainder tells me when I've got variable expressions. Same thing it tells me over here, by the way.
Actually, if that was a 4, wouldn't it be -1? So this is actually would be 6. Y squared plus 4y plus 6 would go in evenly, right?
No.
Oh, no,
It's
okay.
1 over, yeah. It's 1 over. It's got
1
one
over,
extra.
okay.
It's got 1 extra. That's why there's 1 extra there. So if you took that 1 extra away, then it would
Okay.
work. Do you actually have to get what I just said about the remainder telling you? No, you don't have to get that at all. It's just kind of nifty to get it. And that's the process. I can't. So here, try this one.
So you're only dealing with the y when you're dividing it into. You're not messing with the 2. You're just doing-
Exactly. The 2 comes into play on this next part, but the y is really what drives what goes up here, right? Or the first part here. Right? So how would you do this here? See how evil I went? Not too evil yet. Sure. If I make 1 out of thin air, the remainder can certainly get to be like 87 or something silly, but we'll see what happens here. So try to see how far you can get with that.
You said 87, and I went down 84.
Oh,
Because I was.
sorry, man. Believe it or not, it does help to sit down and set up some long division problems just with numbers. Because again, it's been a while for most of us that actually sit down and do long division, right? But the more you remember that step, these are the same steps. That has exactly the same process to it. So what's the first step here? What goes here?
X squared.
X squared, I like it. Because x goes into x cubed x squared times. Or something that might be a little better, what do I multiply by x to get this x squared? Same thing really, but just easier to think about. So x squared times x is
X cubed.
obviously x cubed. It's got to be the same thing. X squared times 3, 3x squared. Change the signs, I love it. That's really that step where we subtract, but if I subtract this, the negative gets distributed, so it's easier just to remember change the signs. And then combine. Those go away like it always should. Then you get
-2.
I like it. Bring down the 5x. Whoa. What goes here now?
Minus 7x.
Minus 7x. So x times negative 7x makes negative 7x squared. Right? Negative 7x times x, we just said, is this. Negative 7x times 3 is, yep, change the signs. Right? Bam, bam.
I think that's where I'm confused.
Yeah, me too. That's where I messed up.
Why would you automatically change the signs when you put a negative or a positive up on top?
So that it would automatically be the opposite?
Are you allowed to do that here? I mean, if I know I want a negative 7 there, would I say 7 goes into 8 negative 1 times?
I don't know.
You do know. 890 divided by 7 can't be negative.
Okay.
So obviously, I mean, what's the process that has been set up? What's the process? And actually, the process hasn't been set up. It's just that this is how we show the process. The process is math. It's just you can't change that. How do we show what's going on? 7 goes in 8 once, put a 7, change its sign.
So you're always going to want to change it.
Yeah, because really, what do I said it that way when I did this, but what do we do? You know you subtract. You know you subtract there, right? So, just to go back real quick, x goes into negative 7x squared, negative 7x times. There's no other way around that, right? That's x goes into this that many times. It's got to be negative to make it negative, right?
Right.
Period.
Okay,
And
so in other words, everything on top has to match what's down below so you can change the sign.
you don't have to think forward like that. You don't have to take all that into consideration at all. Not at all. Here, why was that x squared? Because x times x squared is x cubed. X times what is negative 7x squared? Negative 7x. I don't think, what is the sum of each? No. I don't think any of that crap. I just say, what do I multiply to make it this? Period.
Okay.
So you're trying to think ahead too much. You don't have to think that far ahead.
Okay.
Because it's built in now that when you change the signs, they'll cancel.
Right.
Right?
Right.
So let me see where I'm at. Oh. So now watch this though. If I put negative 7x squared minus 21x, right? And in long division, what's this process? I subtract what I just got. Cool? Right? And that's why we change the signs.
Okay.
So instead of putting that minus on it, we just go ahead and realize that changing the signs is equivalent to subtracting. They're the same thing, of course, right? Subtraction is changing something's sign. So then what do you get there? You get those go away. 26x, bring down the negative 2. So x goes into 26x. 26 times. 26 times x is that thing. Plus 78. Change the signs. Oh, that's funny. I got close to what I So those cancel and I get negative 80. That's funny. Minus 80 over
X plus
3. So this means that if I made this go up by 80, see how it's down 80? If I made this go up by 80, that would actually go into this evenly. Because I wouldn't know that until I did this whole process here, right? It does take a little getting used to, but once you start doing a few, it's exactly the same thing we do with numbers. It's got to be. Variables are numbers we don't know yet. They got to work the same way.
So when you get to a number without a variable, and that's when you know that, like, if you have
Whenever
a
you get to a
remainder-
point, to be more general, let's do one more, and then I'll let you out. I'll do one more that's a little bit harder. And
Yeah, other than that.
yeah,
Yay.
there's 2 ways to make it harder. I could divide by a higher power of x, or I could have something missing up here, right? So let me if you have something missing, let me just address that by itself real quick. If something's missing, like you have x squared minus 7 divided by x plus 1, when you go to set this up, you put a placeholder. I love it. You have 0 x's. You need that placeholder there so you have a place for things to go as you multiply it out. Okay? That's how you take care of that. Be very careful. You need to have everybody represented. If somebody's missing, put down specifically 0 of these guys so you have a place for those to go. The more important thing for right now, I think, real quick, is if I divide by a higher power, am I doing the same thing? Yeah, that's fine. I divide by x squared, let's say, minus 2. Now let's discuss it. Let me see if you guys can handle this, because it has a little extra twist to it. Yeah, so the process is the same, really. You start off with x squared goes into x cubed x times. X times x squared is x cubed. X times negative 2 is negative 2x. Where do I put it? Under the one that's like terms. Why would I put it there? Those can't go together. I'm gonna line up the like terms. We actually have been doing that. We just got lucky that the like terms was the next thing in line. Okay, we didn't get so lucky in that one. Too bad for us, but we still line up the like terms. What do I get? I change the sign, right? So you get that's gone. This is still the same thing. 7x minus 2. Have faith. Because it's a really good question. The question is on the table. I don't know if you realize the question on the table is, when do I know I'm done? It's always a good question. So x squared goes into negative 4x squared minus 4 times. So I get negative 4x squared plus 8. Where's the plus 8 go? Here, right, with the like term. Change the signs. So you get 7x minus 10. Can x squared go into 7x?
No.
You know you're done when the thing you have left is less power than the thing you're dividing by. Because it can't do it anymore, right? So the nice thing is you just collect everything now. What do you get? Plus 7x minus 10 over x squared minus 2. So when you're dividing by a high power, things do get a little bit freakier. If you're missing a step, missing somebody, that's not that hard to take care of. That's pretty straightforward, actually. It's when you divide by high power that some really freaky things can happen. Lining up the like terms, knowing when to stop, those things. All right. Wow. So I have your quiz graded tomorrow, and we'll have another quiz tomorrow. I'll try to make it short, to the point. And then another one the next day.
Did it really tickle?
I know. All right, guys. See you tomorrow. Go get some oxygen.
Nothing.
And I know what I'm doing, I just keep messing up the little